all kind of units, feet, inches. Well, whatever you start with is what you're going to wind up with. So if you start with inches this way and inches this way and inches this way and multiply them together, you're going to get cubic inches. The point is that 3 dimensions multiplied wind up giving you a cubic answer. If we were writing this formula down on paper to find the volume for our rectangular shape, we would write it down by assigning names to each of the dimensions and multiplying the names together. And so, for example, we would say length times width times height, and that would give us the volume of the shape. Now, in multiplication, it does not matter which item you do first. You could multiply any item here first, and then multiply the remaining 2, and the answer is going to be the same. And in the same way, I could, for whatever reason, decide to first multiply 2 numbers together and give it a name, and then multiply it by the third number. And in this case, the name that I wish to give it is called the CSA, the cross-sectional area. In other words, if I find the surface area of an object and multiply it by its remaining dimension, I can also get volume that way. Once again, if I wanted to find the volume of this rectangle, I can first take this surface area by multiplying the length times the width, and then multiply it by the remaining dimension, and that would give me volume. In the same way, I could take this surface area, and I could multiply it this way, and that would give me volume. Well, how could this knowledge help you? Well, this knowledge could help you by showing you a simple way to find volumes on shapes that you may or may not be familiar with. For example, if I were trying to find the volume of this representation of a column which has 4 sides, and then 2 short sides here, one way I could do it, of course, would be to multiply length times width times height, but perhaps an easier way might be if I knew the surface area of this one facing side. All I would then have to do would be to multiply it by the remaining dimension, and that would give me volume too. In the same way, if I had a shape such as a cylinder, and I wanted to find the volume of this cylinder, one way I could do it would simply be to find the surface area of the top. Now this, of course, is a circle, and I would need to know the formula for finding the area of a circle. But having found the area of the top, I could then multiply it by the remaining dimension, and that would give me volume also. So therefore, I don't have to regard that there's a separate formula for finding the volume of this shape. All I have to do is keep in mind that 2 dimensions multiplied together give me a cross-sectional area, or if I simply have the cross-sectional area to begin with, all I need to do is multiply it by the remaining dimension, and that will give me volume. Another concept that can help us in this effort has to do with something called the centerline perimeter. Imagine, if you will, that this is a foundation for a house, and it's extending around the rectangular shape of the house. We're looking down at it. Now, if I wanted to measure the perimeter of this house, or this foundation of the house, I would have 3 choices. The first is I could walk around the outside, and if I did that, I would get what I could call the exterior perimeter of the house. Or I could walk around the inside, and I would get what would be called the interior perimeter of the house. But suppose I wanted to walk dead center along this footing all the way around. If I were to do that and measure it, I would find what is called the centerline perimeter of the house. Now, why is this important? Well, we already said that if we knew a cross-sectional area, we would then be able to use that to multiply it by the remaining dimension to get volume. So let's say I saw a cut section of this footing, and when I looked at the cut section of the footing, I could see the cross-sectional area of this footing. And perhaps I could measure or even calculate what this cross-sectional area was. And knowing that, I'd want to multiply it by the remaining dimension, which would be the perimeter around this footing. But the question is, should I use the exterior perimeter, should I use the interior perimeter, or should I use the centerline perimeter? And the real answer to this question is, which perimeter represents the actual length of this footing? If we were to break these pieces apart, which would show us the real length of this footing without double counting any of the corners? And the answer, of course, is the centerline perimeter. Now, to determine the centerline perimeter of this footing, we're going to have to perhaps adjust some measurements. For example, if we were shown on a set of plans that the exterior measurement from this point here over to this point here was, say, 4 feet. and we were told that the footing was 1 foot wide. In order to get us to the center point here, and the center point here, we would have to back off half the thickness of the footing here, and half the thickness of the footing there. Well, that's a half a foot, and that's a half a foot. So if our exterior measure from here to here was 4 feet, our center line measure from there to there would be 3 feet. This works the other way too. Having determined the centerline perimeter of a shape like this, we could then multiply it by the cross-sectional area of the footing, and we would have volume. Now this method takes some getting used to, but it's very important that you recognize it, because this is how you're going to find volumes for irregular shapes. Shapes such as twisting and winding curbs and gutters, shapes such as entryway stairways into a building. In all of these cases, the easiest way to do it is to find the cross-sectional area and multiply it by the remaining dimension. Returning to our cram book, we have just discussed reviewing these concepts, A, B, and C, the center line measurement and the cross-sectional area. Number 6 tells us that when we're looking at a problem for the first time, don't read the whole thing. Look for the exact question first. And what I mean by that is that there's only one sentence that is the question. Whether the entire representation of the question is 5 paragraphs, 10 pages, it matters not. There's only one sentence that is the question. And we kind of have to unlearn how to read chronologically. That's how we were taught in school. We want to read for result, and therefore we're going to scan a question first and zoom in on the exact sentence that we're looking for and try to understand what they are asking for first. Here is the best investment of your time. 7th step is to double check what you're doing. You might find this ironic, but when you actually get into the exam, you're going to observe many students grabbing their calculators and immediately starting to punch them. For practical purposes, you can guess that each one of those students has just failed the exam. The real key to this exam is to be consistent and careful. This exam is not difficult the way most people think it difficult might be. Any one of us could add 1 plus 2 and 2 plus 3 and 5 plus 4. We could add them and continue to add them time and time again. But if we were under pressure and we were asked to add them consecutively very quickly, the odds are we're going to make a mistake. And that's what the test is seeing. The test is seeing if you can solve problems under pressure without making simple arithmetic mistakes. And the way you solve that, the way you accomplish passing the exam, is by being consistent and by double-checking what you're doing. Point number 8 deals with reading a set of plans. And you will see more detail on this when we do some more in the cram workbook. However, normally when reading plans, you look at the numbers and you kind of eyeball the numbers with respect to the drawing, and that's how you get dimensions. In these plans, however, the numbers are deliberately misleading. They're placed in the wrong place. You look for the dimension points first. That is to say, you define exactly the beginning and the end of what you want, and then look at where the numbers are and what the numbers are representing. If you look at the numbers first, like you're normally doing with a set of plans, you will misread the numbers. Look for the dimension points first. Step number 9 is important. Keep a sense of humor. If you don't have one, go out and get one. This is just a test. You're going to survive it, you're going to pass it, and you got to have a sense of humor. Finally, have a professional, positive attitude. Pretend these issues involved your money. If you did so, you would double check, you would be careful, and you would be consistent. And if you approach the exam in this fashion, you're going to pass it. There you have the first module. Hopefully we've been able to share with you what the test is going to be like and how these modules are going to move forward. We think you're going to find them interesting. Certainly if you have any questions during this module or any of the other modules, feel free to bring them into your instructors. I hope you'll attend the workshops. And I'm Bob Tannenbaum, and I'll see you at the cram.